Last class we dealt with using molar mass. Okay, and when we used molar mass, we were able to convert from grams to moles and moles to grams. Would you agree? Molar mass, its units, molar mass units are grams per mole. So that allows us to convert between grams and moles, right? Avogadro's number is 6.022 times 10 to the 23rd. Okay, and that tells us how many atoms are in 1 mole. Okay, so that allows us to convert between atoms and moles, or molecules and moles, whatever it happens to be, right? Avogadro's number works for any substance. So it could be atoms, could be molecules, could be baseballs, donuts, whatever it is, okay? So now we're going to take molar mass and Avogadro's number, and we're going to be able to convert between grams and atoms. So we're going to take the number of grams of a substance and be able to convert it all the way to atoms. Okay? So if I have a 10-gram sample of carbon, we're going to be able to tell exactly how many atoms of carbon are in that sample. Okay? Or if I have however many atoms of oxygen, I'm going to tell how much that would weigh in grams. Okay? So if we know that we can convert between grams and moles using molar mass, and we know we can convert between moles and molecules using Avogadro's number, what's the middleman between grams and Avogadro's number? Moles, right? That has to be the connector between those two things. So we have to look at moles in between those. So there's no way that we can convert directly, like one step, from grams to molecules or grams to atoms. Moles has to be our middleman here. So we'll still use a T-chart. We'll still look at all these things, except now moles is going to be our middleman. So our T-chart will be 3 sections instead of just 2. Right? We're just adding one step in there. This would be like when we did conversions between, our metric system stuff. Meter was always the middleman, or gram was the middleman, or whatever that base unit was, that was our middleman, right? We'd go there and then go back. That's what moles is, right? We got to get through moles before we can convert to the other, okay? We're going to use the same T-chart conversion, except we're going to have 3 spaces. So this is kind of what it will look like. Let's dive in with an example here. How many salt molecules are in 14.52 grams of salt? Okay, so we're starting with grams. We want to go to molecules. Okay, so in our T-chart, we're going to write what we know. And we draw our T. Okay, so if we want to go from grams to molecules, where do we need to go? Grams to what? Moles to molecules. Grams to moles to molecules. So I want to get rid of grams and go to moles. So grams goes on the bottom. And I go to moles. Right, that's one section. And we're going to go ahead and do all the units first, and then we'll come back in and fill all the numbers. Okay, so if I want to get rid of moles next and go to molecules, where does moles need to go in my T-chart? Bottom right. Okay, so now I can go back in and start filling in my numbers. What does moles always get? The 1. So in both spots, moles gets the 1. What number always goes when it's molecules or atoms or whatever? Good. Avogadro's number always goes here. Okay. And what number always goes with grams? What always goes? How many grams are in 1 mole? This is always molar mass. Okay, so with the unit grams, has to be molar mass, always. Okay? Oops. Okay, so we need to calculate the molar mass of sodium chloride to put in there. Good. Yeah, 58.45 or 58.5. Either way you round that is fine. Okay, are we clear with where all these numbers came from? Yeah. Okay. So it's no different. We're just adding a section to our T-chart. We're taking it one step further. Okay, so we go from grams to moles. So we've canceled grams. We've canceled moles. And we're left in molecules, which is what we want. Okay, so we multiply across the top, divide by the whole bottom. Should we be expecting a big number here or a small number? We're looking at number of molecules. Should that be a small number? No, it should be a big number. It should be a huge number. 1.49 times 10 to the 23rd. You have to look to the end of your calculator. If it says E23, that means it's times 10 to the 23rd. Okay, and you should be knowing here that we're solving for molecules, which means you should end up with a huge number, okay, which this is considered a huge number. Okay, molecules, put your units on there at the end, molecules of NaCl. Okay, so now we can check. Remember how we talked about last time checking to see if our answer made sense or if it was reasonable? We're going to do that same thing here, okay? Look at our molar mass of sodium chloride. Okay, if we know 1 mole weighs 58.5 grams, did we start with more than or less than 1 mole? We started with less than 1 mole. Okay, so that means our answer, right, we're not changing amounts of our substance throughout the whole problem. We're just converting the unit. So the answer should be less than or more than Avogadro's number. Less than, right? It should end up being less than Avogadro's number. Okay, because we started with less than 1 mole. We didn't change anything. We're just changing the units. So we should end up with less than 1 mole. Is this number less than Avogadro's number? Yes. So our answer makes sense. Okay, that's all the more that you don't even have to do that part of the problem. It's just a way for you to check yourself to make sure you didn't flip-flop something in your T-chart or do something funky. Okay? Questions about that problem? Okay. How many grams are in 6.244 times 10 to the 23rd molecules of NaOH? Okay, so we're starting with molecules this time, and we're going to grams. And what does the process need to be? Molecules to what? Good. Molecules to moles, then to grams. So we want to go molecules to moles. From there, what needs to be the next step in my T-chart? Grams goes where? Good. Grams here. We want to get rid of moles, so it goes here. Very good. Okay, and so what does the mole always get? The 1. Okay, what always goes with molecules? Good. Okay, and I don't want you to necessarily even try to memorize it like that. I want you to think about in terms of, how many molecules, if we know that moles gets the 1, how many molecules are in 1 mole of anything, right? So you should just know that that's got to be Avogadro's number. If you think about it in terms of, I'm only looking at this section right here. So I know 1 mole is equal to how many molecules? Okay, and it's got to be 6.0 to 2 times 10 to the 23rd. Okay, what goes with grams, right? You're trying to find out how many grams is in 1 mole of sodium hydroxide, okay? And so we calculate our molar mass there. So 23 plus 16 plus 1, and we get about 40 grams. Would we agree there? Okay, so now we multiply across the whole top, divide by the whole bottom. Make sure that you're either using parentheses or that exponent button. All right, Sarah, what'd you have? Do we agree? Good. Yeah, that's exactly what I had. Very good. Anyone not getting that to come out in their calculator? Okay. Okay. We started with greater than or less than Avogadro's number. Right, just barely greater than, right? So we started with more than 1 mole. So our answer should be just barely greater than 1 mole in grams. And is it? Yeah. Yes. Okay, so does that part make sense or not so much? Yes. It doesn't affect your problem. It's just a way for you to kind of check yourself. Okay? So this is larger than Avogadro's number, so that means we started with more than 1 mole. That means we should end up with more grams than 1 mole, right? We know 1 mole of grams of sodium hydroxide weighs 40. We should have just over that, which is we did. Okay? All right, you want to try this last one on your own? So are we expecting a big number or a small number? A big number. Anytime we're looking for atoms or molecules, we should be expecting a big number. So, Grant, why don't you tell me what you got?
2.04 atoms.
Did you have times 10 to the something? Yeah, you can't forget that. I got 24 also, actually. It's okay. If we just write 2.04 atoms, are these two numbers the same? Not even close, right? This one is really, 204,000,000, with 22 zeros tacked onto the end. Okay, so that's a lot more atoms than 2.04. So don't just leave off that times 10 to the something. Yeah.
I thought we did US conversion, how there could be per second series, multiple units in between. Is there going to be any more units?
Nope. Nope. Moles is going to be just our middleman. Yep. So this is as complex as our conversions will get right now. Okay.